Good afternoon, spaceflight enthusiasts, and welcome to another episode of The Angry Astronaut. We are going to be discussing Mars once again, this time in regards to another NASA SpaceX initiative, and that is establishing a permanent presence on the red planet for the human species. Even though it's been discussed a number of times that NASA really doesn't have any ambitions beyond establishing a small-scale research base permanently on Mars sometime in the future, what they've actually published suggests otherwise. There is a new paper that just emerged that was put together by NASA researchers across the country utilizing SpaceX Starship as the primary means of transportation and even the primary location for habitation for at least early Mars colonists, all suggesting an end result of establishing large settlements on Mars and ultimately even cities. Definitely a permanent colonization objective. And they go through a great number of details, especially in regards to the unique payload capabilities of Starship and why this looks like a very optimistic way of establishing a large-scale human presence on Mars. However, that's not the end of the story. There's another group of researchers at the European Space Agency who have also reviewed Starship's capabilities and SpaceX's rather vague plans of not only getting to Mars and establishing a presence there, but also getting back. And even though Elon is talking so optimistically about the idea of sending the first humans by 2028, ESA has come to the conclusion that based on SpaceX's published capabilities for Starship, and of course there's a lot of things that they don't include in their plan, but in terms of what Starship is publicly advertised as being capable of doing, once all the numbers are fed in and once everything has been tabulated, it's been determined that there's a number of things about this plan that are just not viable. And this actually includes coming back. So when I got this paper sent into my inbox a few days ago, it came as a bit of a surprise to me that it's taken this long for NASA to put together a plan of establishing a permanent presence on Mars using Starship. I've seen lots and lots of papers that involve SLS to one degree or another, but given the fact that NASA has embraced Starship as the choice for HLS for putting humans back on the moon, it seems logical that they would also pursue the possibility of using it for Mars. But this is the first paper that I have seen thus far that embraces this technology and actually has it in the title. The title of the paper is, quote, Mission Architecture Using the SpaceX Starship Vehicle to Enable a Sustained Human Presence on Mars. And from the very first paragraph, it sounds like that Elon Musk himself might have written it. Quote, a main goal of human space exploration is to develop humanity into a multi-planet species where civilization extends beyond planet Earth. This article focuses on a mission architecture using the SpaceX Starship as cargo and crew vehicles for the journey to Mars. The first starships flown to Mars will be uncrewed and will provide unprecedented opportunities to deliver 100 metric tons of cargo to the Martian surface per mission and conduct robotic precursor work to establish a sustained and self-reliant human presence on Mars. We propose that the highest priority activities for early uncrewed starships include pre-placement of supplies, developing infrastructure, testing of key technologies, and conducting resource prospecting to map and characterize water ice for future future ISRU purposes. By the way, ISRU stands for In Situ Resource Utilization, something that is going to be absolutely crucial if we want to establish a permanent presence anywhere in the solar system. The pathway for a sustained human Mars exploration includes Step 1, uncrewed landed missions to Mars, followed by Step 2, human landed missions to Mars with relatively small 10 to 20 person crews to establish the first human presence on the planet. And then number 3, advanced infrastructure development to support planned community growth. And then number 4, transitioning to a self-sufficient state on Mars. The fourth and final condition requiring sustained in situ resource utilization, which is the ability to survive on Mars using local resources and eliminating the reliance on Earth for long-term survival. Now, the most valuable resource on Mars is going to be probably the vast deposits of Martian water ice that we know exist either on the surface or just below the surface. Water will be required for life support, agriculture, and will also be utilized through electrolysis to produce hydrogen and oxygen for use in fuel cells and rocket engines. Each kilogram of consumable material transported from Earth incurs a penalty of about 200 kilograms of propellant to launch, transfer, and land on Mars, depending on vehicle specifics. So it's very important indeed that Martian colonists make use of the resources on the red planet rather than carting it from Earth, even utilizing vehicles like Starship that have vast payload capabilities but still require lots of propellant to get resources out to the red planet. So here's the Starship mission architecture as NASA has it laid out, at least right now. We consider a Mars mission architecture predicated on the SpaceX capabilities and vehicles. For the purposes of this article, we make the following assumptions regarding the SpaceX capabilities and outline a candidate mission and architecture accordingly. We assume that initially, at least 2 uncrewed Starships will be launched to Mars. These uncrewed vehicles have the capability of landing within close proximity of one another, but with 1 kilometer spacing in order to avoid damage induced from landing pads and lofted regolith. That's going to be a real problem, not only on Mars, but also on the moon. Loose regolith and rocks in a low-gravity environment, and Starship's immensely powerful Raptor engines are going to create lots of debris, so you want to make sure that these ships land at least a kilometer apart from one another. They can also land in separate regions of Mars if the in situ reconnaissance is warranted in different locations to determine the final landing site for the crewed missions. The arrival of Starships at Mars could also be staggered by 1 to 2 months, such as the landing site assessment can be performed with data returned from the first Starship before deciding on the final landing site for the second. Now, even though Starship is reusable, of course, the first uncrewed Starship should remain on the surface of Mars indefinitely and serve as an infrastructure for building up the future human base. Launch windows from Earth to Mars occur approximately every 28 months when Earth and Mars are optimally aligned for interplanetary travel. Now, the second wave of launches would include 2 or more uncrewed vehicles plus at least 2 crewed Starships, and all of these vehicles can land at the preferred landing site for construction of the human Martian base. Starship launches can continue at each subsequent launch opportunity, in other words, every 28 months. An optimal plan is for the total number of landed vehicles to double at a minimum with each consecutive opportunity, with a to-be-determined split between crewed and uncrewed vehicles. This is a very ambitious plan. It means the next launch opportunity would have 8 Starships, then 16, then 32, then 64, Very ambitious thinking on NASA's part, something that's very much in line with what Elon Musk is thinking about colonizing Mars. It also covers Starship's specific capabilities. We know most of these things. It's launched by the Super Heavy vehicle, of course, which is also fully reusable. And given its expected payload capacity, Starship is able to transport the necessary equipment to support sustained human exploration, as well as the crews, enabling the eventual establishment of cities on Mars. Musk outlines how SpaceX missions to Mars will utilize in-space propellant transfers. In this case, the booster launches Starship into Earth orbit, where it's refilled with methane and oxygen by additional tanker flights from Earth. Tankers are starships that carry only propellant as payload. The boosters and tankers return to the launch site for reuse, and the refilled Starship vehicle then travels to the surface of Mars. Refilling Starship in orbit essentially resets the rocket equation, allowing for large payloads to be transported in a way that hasn't really been possible in the past. So the first human-rated flights to Mars are going to have at least 2 cargo starships already there to take advantage of, and the human-rated starships will have on order of 1,100 cubic meters worth of space in their fairing, although not all of that's going to be habitable, perhaps 55% of it or so, based on how things work on the International Space Station, with the amount of space that has to be reserved for equipment, operation systems, life support, that sort of thing. So probably around 600 cubic meters or so will be habitable out of that 1,100. But in addition, it also has an 800 cubic meter liquid oxygen tank and a 600 cubic meter liquid methane tank that could be converted into habitable living space as well. The study recommends that the first crewed starships each have about 10 to 20 people on board, with an additional 100 metric tons worth of available cargo mass per starship. Cargo carried on these flights will necessarily include additional equipment required for human health and productivity during the transit to Mars and on the Martian surface. These vehicles will also carry fully operational hardware needed to support the human Mars base, which is likely to include equipment for power production, water extraction, pre-prepared landing pads, radiation shielding, dust control equipment, and exterior shelters for humans and equipment. Humans will likely live on Starship for the first few years on Mars, so these starships are going to be the habitation structures for human colonists. That can also be problematic, and something that the report spells out, because we don't know how good of radiation protection starships are really going to provide to colonists, meaning that the radiation risk for the specific landing site where the humans are going to set down must be assessed and mitigated accordingly ahead of time. That means that the first wave of uncrewed Starship vehicles needs to assess a lot of the conditions and set up a lot of infrastructure before humans even arrive. Arguably, these first 2 unmanned starships are going to be more important than any of the starships that come afterwards. So, what are these starships going to do? Well, perhaps the most important task that the unmanned starships and their robots on board are going to carry out is the extraction and exploitation of water ice. It is estimated that at least 0.6 kilograms per hour per person is going to be necessary for human consumption, hygiene, and everyday living on Mars based on International Space Station data. This estimate will be higher for a longer-term base on Mars because there's fewer restrictions on water use, such as using more water for personal hygiene compared to the ISS, and also more water for things like laundry and cleaning dishes. and the amount of water required per person will also increase as the Mars community grows and will include activities such as regolith processing, manufacturing, construction, perchlorate, remediation, in other words, rinsing all the toxins out of the Martian soil, plant growth, habitat maintenance, etc. So when designing water treatment and distribution systems for Mars, it's important to recognize that there will be various uses for water, which will have different requirements of purity. And in addition to supporting human survival, water will also serve as the main source of propellant and oxidizer production on Mars. Propellant will be primarily used to allow Starship vehicles to return to Earth with both cargo and crew. Starship has an oxidizer to fuel ratio of 3.5, meaning that the 1,200-ton propellant capacity of Starship, 933 metric tons of that is oxygen, with only 287 metric tons being methane. And methane is mostly comprised of materials that you can find inside water, because methane, after all, is CH4, one carbon atom, and 4 hydrogen atoms, meaning that all you need really is one carbon atom, and the rest of it being materials you can get from water. And incidentally, how do you manufacture methane on Mars? Because even though methane exists on Mars, it's not all that common. Definitely there have to be other methods to create methane for SpaceX's Raptor engines, but it's not a very difficult process. You combine CO2, which is present in the Martian atmosphere, plus H2O, utilizing electrolysis and the Sabatier method to create one methane atom and 2 oxygen atoms, meaning that this reaction can create both oxidizer and methane for a methylox engine. Starship is actually very well suited for Martian operations, far better than it is suited for the moon, to be honest. But all of that having been said, it's obvious that this type of resource needs to be exploited as much as possible and as early as possible if a Starship-based expedition to Mars is going to be successful. So how do you access this type of resource? How do you find the ice? How do you extract it? Well, ironically, a project designed for the moon, Project Viper, which most of us are familiar with, was a water-sniffing robot that could have worked on Mars as well as the moon, and yet, as we all know, that project was canceled recently. But there is another project that you're looking at right now called Red Water that is being designed by Honeybee Robotics, and even though it doesn't really sniff out water, once a suspected cache of water ice is discovered, it's capable of mining it to a depth of 25 meters. Red Water implements 2 proven technologies that are already used in Antarctica: coiled tubing for drilling and a system called Rodwell for water extraction. And the way it works is at the end of the coiled tubing tube, there is a bottom hole assembly, which is a motor and a drill bit for drilling into the subsurface. To remove chips, compressed Martian air is pumped down the tube. Once the hole is made, the coiled tubing is left in the hole and used as a conduit for water extraction. Upon reaching an ice layer, the drill continues for another 3 meters or so and then stops advancing forward, but the bit continues spinning. The drill deploys a flexible packer to seal off the hole, and subsequently built-in heaters are turned on to melt the surrounding ice. After melting a section of ice, the borehole is further pressurized and a valve opens to allow water to flow up to the surface tank as in terrestrial geysers. But this system is going to have a huge task ahead of it because a prototype red water system was designed and tested in a 25-degree below 0 Celsius block of ice and created approximately 15 kilograms worth of water in 2 hours, meaning that this could create up to 1 metric ton worth of water in 10 days. And you need to create hundreds and hundreds of metric tons of water just to produce enough fuel for Starship to get back home, meaning that you would probably need dozens of these robots just just to mine enough water to produce fuel for Starship, let alone everything you're going to need for the base as well. That is an enormous task and something that is probably going to consume a considerable portion of the first 2 Starship's payloads before human beings can even think about traveling to Mars. Because it's not just a question of mining the water, you also have to purify it. You need to store it. You need a distribution system. You could possibly do this with trucks of some kind, but a piping system would be a lot better, meaning that you need to set up a small-scale municipal water system. All of this being done before the first humans even arrive, and it gets even more complicated because we're only just talking about one resource here. What about power? Well, you're going to have the deployment and operation of a power infrastructure in place before humans arrive as well, because obviously the availability of power is critical to surface operations. For the first landed missions, you're probably going to have batteries and solar arrays with a backup power source, possibly chemical fuel cells of some kind derived from hydrogen, again from that water source. Man, water is important to Mars colonists on so many different levels, but ultimately nuclear power is going to be absolutely essential given the unreliable aspects of solar arrays in the middle of dust storms and other problems on Mars. Now, a Hyperion reactor, a Hyperion small-scale nuclear reactor, only weighs about 20 metric tons and produces about 25 megawatts of power. So assuming SpaceX can get access to a nuclear reactor, which by the way will be a lot easier if they're doing this mission in conjunction with NASA, then a nuclear reactor will only consume about 20% of the payload of a single Starship and will be able to provide all of the vast power requirements that this colony is going to need, even from the beginning, assuming that you're having to mine all of that water, which you're going to be absolutely required to do. If you don't mine enough water to completely refuel Starship, that means if anything goes wrong, your colonists can't get home. They're just going to die, and that is an unacceptable risk, especially as far as NASA is concerned. In addition, these first unmanned starships can do environmental characterization, provides an unprecedented opportunity to collect environmental data at the landing site, which will be valuable for the design and construction of future equipment and infrastructure to be flown from Mars. A basic weather station, for example, to measure atmospheric and surface temperatures, wind speed and direction, atmospheric dust content, atmospheric pressure, and radiation levels especially is necessary in order to minimize uncertainty for the environmental conditions expected by human colonists when they arrive. Also, testing high-risk items will be a good thing to do on unmanned starships. It will also need to carry substantial amounts of radiation shielding, because if these starships are going to be used as habitation structures, at least for the first few years, a stainless steel hull is not adequate protection from radiation. These unmanned starships would be well suited to carry additional radiation shielding for use by the arriving colonists a few years later. Another critical job for these initial starships will be landing site preparation. It will be very difficult for starships to land on untreated regolith in the first place, and landing human-rated starships on regolith is going to be all too dangerous, probably more dangerous than NASA is willing to risk. So the unmanned starships can prep a landing site ahead of time. There's a variety of ways to do this in terms of melting or leveling off the regolith in order to form a crewed landing pad for future starships to set down on. Fortunately, SpaceX has proven to be extremely effective at landing Starship precisely on target, at least thus far, and they should be able to hit a landing pad target once it has actually been built. Then you have things like food production. That is going to be immensely complicated, perhaps too complicated for these initial starships. Perhaps the first humans to Mars should have enough supplies in order to be able to survive on in a pinch if they can't get their own food production going, and the unmanned starships could pre-position valuable supplies, including food for the colonists, ahead of time. Again, it appears that these first unmanned starships are going to be absolutely crucial to the success of a Starship mission to Mars, and especially building a colony overall. And given the fact that Starship has such massive requirements when it comes to fuel anyway for going back to Earth, it means that in situ resource utilization is going to be even more crucial than any mission that's been planned to Mars up to this point. So here's the big question then. Is all of this really possible? Is something this ambitious, something that requires this much infrastructure and this much payload to be brought to Mars, to exploit this much in the way of resources to make it all successful? Can we actually do this in the foreseeable future? Well, certainly not in the next 4 years. I think all of us can agree on that. Elon's idea of sending humans by 2028 is a pipe dream. Any prospective Martian colonists that make the trip to Mars before Mars has the necessary resources to support them are going to be sent on a suicide mission. We need to make sure that the necessary resources to keep these people alive are in place and have been properly exploited, stored, and are ready to be used before humans make the arrival. Because unlike the moon, we can't just abort the mission and come back in 3 days. Any unsuccessful mission is probably going to have to wait 2 years before a return is going to be manageable. And as we've already mentioned, you can't return in Starship unless you mine the necessary resources to make the propellant and oxidizer. This is going to be an extremely risky endeavor and something that's going to require a lot of preparation and a lot of unmanned missions before a manned mission is going to be conceivable. But even if all of this is done, is it still possible? Well, in our next episode in this 2-part series, we are going to explore this. I was kind of hoping to get this done in one episode, but there's entirely too much to cover. The European Space Agency took a great deal of time researching SpaceX's plan to see whether or not it's actually feasible in the real world. And the results were interesting indeed. So until then, please don't forget to like and subscribe. Please consider supporting this channel on Patreon. It's so important to my ongoing survival as a YouTube creator. And as always, stay angry about space.